to talk about angles. So I want you to look at the pictures on the top. One shows an angle, the green piece shows a 12th of a fraction circle, and the yellow piece a 4th of a fraction circle. Imagine we're measuring the above angle right here using fraction pieces. We want to know how many wedges or fraction pieces will fit inside that angle. So think about this. How many green pieces would you estimate fit inside the angle? I'm going to look at my green piece and the angle right here. It looks like at least one would fit, right? At least one of these green pieces. And I would maybe even say 2 or 1.5. I think all of those would be good estimates. So I'll maybe put 1.5 pieces. Now let's try the yellow piece. How many yellow pieces, or not pieces, would you estimate fit inside the same angle? Well, look at this. This yellow piece is already going to be bigger. So it won't even, so 1 is too big. It's going to have to be some fraction of a yellow piece. I'd say maybe like 3/4 of the yellow piece would be the right size to fit in the angle, maybe like that, right? So I'm going to estimate anything under 1 is reasonable. I'll say maybe 3/4 of a piece. Now the big question, why are these two measurements different? We were measuring the same angle. Why were we different? Well, of course, they have different units. Right? All right, different units. And that shows us, just like with anything, we need a standard unit of measurement. And there is, in fact, a standard unit of measurement for an angle. Do you know what that is called? Well, I'm going to show you on the next slide. The standard unit is called a degree. Give a woohoo if that's what you were thinking. And it actually has a cool little symbol, right? If I wanted to say 1 degree, you draw a small circle in the upper right of your number. Now, this picture, isn't this really fun to look at? So this gives you a sense of how small a degree actually is. It actually gets so blurry in here you can't even see it, but this shows a full circle. A full circle, you might know, has 360 degrees, and you've probably heard that maybe as in figure skating or other sports where you do a 360 turn, means you make a full circle. If you do a 180 degree turn, that would mean you just go halfway around, right? And we, of course, know our favorite angle, a right angle. I don't know why it's our favorite. Just a nice round number. A right angle would just be 90 degrees, like here. And this picture starts to give you a sense, sorry it's blurry, but at how small 1 degree is. I can't even trace it. And it gets all blurry in here because it gets so small. We'd have to really blow this picture up in order to see the 1 degree angle because 1 degree is a very tiny unit. Now let's review some of our angle vocabulary. An acute angle is an angle that measures less than 90 degrees. So we've already been using that word degrees long before we even officially learned it. Obtuse angles measure more than 90 degrees, and I like to say that one like obtuse angle in a deep voice, picturing it as a big wide angle. And my personal favorite, the right angle measures exactly 90 degrees, also known as a square corner, also known as a quarter turn. And here's a new vocab term for you. Perhaps you've heard it before, but this is the first time I'm discussing it with you. A reflex angle. Say that with me. A reflex angle. And that is an angle that measures actually more than 180 degrees. So see, this would be 180 when it, oh, I don't know why that made a shape. This would be 180 when I got to here, a straight, crossing along a straight line, but it keeps going even farther, so that's a reflex angle. We also notice on this, if we were talking about this angle in red, what would that one be? What type? That would be acute, of course. But since it wasn't labeled, the blue one was labeled first. That's why that was showing actually the reflex angle there. So keep those terms in mind. You'll use them again today, but we're going to get some practice estimating with our degrees and with our vocab. First, let's do the vocab part. Angle vocabulary, label these angles acute, right, or obtuse, then estimate the number of degrees they each measure, period. Okay, so let's start with the vocabulary. Go ahead, try that out on your own. Play it back when you're ready to see the answers. So you should have said for the first one, it is a cute little angle. Give a woohoo. You agree. The second one is an obtuse angle. Give a woohoo. And the third one is, of course, a right angle, and we know that particularly because they've drawn for us that symbol. Whenever you draw a right angle, I want you to always label it with that square corner symbol so that we can be sure we know it's a right angle. Okay, so now on to the fun part. Estimate the number of degrees. Doing this reminds me of when we used to use benchmark fractions, benchmarks to compare fractions, right? And we would look at 0, 1/2, and a whole to help us. Well, I'm going to use benchmark angles, right? And the right angle is a really big benchmark to use. So this angle, we already know it's acute, so we know our estimate's going to be less than 90 degrees. I like to actually draw on here, sketch roughly what a 90-degree angle will look like, and then I can see kind of what fraction this is taking up or how close this is to 90 degrees. So just so for your reference, right, if we have a 90-degree angle, if we had split it exactly in half, then half of 90 would be 45 degrees. That's kind of actually another benchmark to use, right? And if I look at this one, to me, that looks like it's a little more than halfway, right? If I wanted to draw like the halfway would be right in there. So I'm gonna say maybe that's like 10 degrees more. I would estimate that one at around 55 degrees. Now, this is an estimate, so there's more than one right answer. I'd say if you were, as long as you said something more than 45 degrees and less than 90, it's reasonable. You want to make sure probably, I'd say, be within plus or minus 5 degrees of my estimate, but we're just learning. So again, just try to make sure it's reasonable. If you had said that this angle shows 100 degrees, well, that wouldn't make a whole lot of sense because we already know it's an acute angle. You want to make sure your estimates are reasonable. Okay, let's go ahead and try this one, the obtuse angle. Pause the video and try estimating it on your own. Don't forget to use your benchmarks. Okay, I'm going to try myself here. We'll see how close we come. So I'm going to estimate, or sketch, sorry, the 90-degree angle. And now I see this one is more than 90 degrees. I don't know, I'd say that's maybe like 15 degrees more than a 90-degree angle. So I'm going to put my estimate as 105 degrees. How close was that to your estimate? Was it within 5 degrees plus or minus? I'd say that was a pretty good estimate on both our parts. But again, if we look at this, it would be crazy if your estimate had been 180 degrees. Like, no, that would be a straight angle, right? That would go all the way to here. So it's clearly less than that. Or if your estimate had been 85 degrees, we'd say, what? It's an obtuse angle. We already know it's more than 90. So make sure you're giving reasonable estimate. And the last one, of course, is easy to estimate because we're told it's a right angle. This one you have to get right on the nose, 90 degrees. We're not given any wiggle room on that estimate because this one is precise. And later, actually, with these, you'll learn about a tool for measuring angles precisely. Do you know what that is called? Perhaps you've heard of it. It's a protractor. So we'll talk about that later in the year, but for now, we just want you to have a good sense of angles, to be able to look at them relative to the benchmark, and to know what type of angle you are talking about.